When people talk about clean energy, they usually talk about where it comes from, the wind, the sun, the movement of nature. But very few people talk about what happens after the wind slows, after the sun sets. This episode is about energy as a system, how it's captured, stored, protected, and finally trusted. So this is the system, right, that you guys are using for this building, right?
Yes, these are the energy storage system for the campus. So we have 5 cabinets here, totally 1.3 megawatt hour of the system. So we actually store the excess energy generated from the PV panels upstairs, and we will store them in the system and release them during the night and off-peak hours to maximize usage of the PV energy.
How big are these solar panels?
Well, we covered 8,000 square meters of the rooftops with solar panels, and we built a 1.5 megawatt of PV system here.
So what is the process of the energy system once it's installed? Explain to me what happens next.
Okay, so we have the PV system here on the rooftop. They absorb the energy from the sun, and instantly through the inverter, we're feeding the power generated from the solar into the grid network.
Okay.
So it will consume instantly by this workshop building, and the extra energy will be stored in the batteries. So we actually performing the generation, storage, and usage scenarios here, and with our concept of multiple energy complementary, it's an ecosystem. So to ensure the maximum usage of the renewable energies, we build batteries for it. That's why we can store the exceed the energy for later use.
This episode isn't about how much electricity was generated. It's about how humanity is learning to trust energy. So this is your product. Explain how this works.
Well, this is our immersion liquid cooling battery storage energy system. So as you can see, on the right side, these are the core components, the battery packs.
Yeah.
They're all connected with the pipe for circulating system. The hot coolant will come out from there and then go to the top for heat exchange and go back to the packs again to keep the battery cells cool. On the left side, these are the major component, the PCS. It's responsible for AC and DC conversion. On the bottom, these are the switches and the AC connections, also the fire suspension system. So to keep the liquid running, we also have a pump underneath to moving the liquid around. So here we are looking at some of the application scenarios of the battery energy storage. So this is the grid forming utility scale BESS. It's especially for cities or a grid network to balance and to do EV charges. So you can see it's a massive scale.
Yeah.
So these are our buildings. Yeah, and also these are the step-up stations to connect it to the grid. So at the multiple MV stations to push the energy into the grid.
The climate and power grids vary obviously across the regions of the world. In extreme temperatures or even without a power grid, can your energy storage still operate stably?
Well, we've delivered tons of projects in a weak and isolated grids with multi-energy complementary smart microgrid system, like say in mining area and in oil fields. We can deploy these projects in weeks and have the peak performance from day one. With the immersion liquid cooling technology, we can plan these projects from scorching heat to freezing cold areas with limited maintenance needed. So we can build this smart and reliable system and adopts almost anywhere in the world.
Energy, I learned, is not stable by nature. It arrives on its own terms. And if you're not ready for it, you lose it. That's why storage matters, because storage is memory. So what is the process of putting your product together?
Okay, so let me introduce to you. This is our fully automatic battery packs production line. As you can see, the robot hands will carry the battery cells there for the quality inspection first. And after the inspection, the battery will be grouped into strings. So into strings, and then we will move in there for laser welding and cabling of the batteries. And then after that, the robot hands will carry the battery cells into there. So you can see they are stacking one by one. So there will be like around 13 of the battery cells to be a one group. Yeah, so there will be 4 groups inside the entire packs. This is our final assembly workshop.
Yes.
So all the components that we made upstairs in the workshops, they will be finally assembling here into this container. This is a 20-foot container with 5 megawatt hour of capacity.
Okay.
Yeah, all the packs will be installed inside. All the high voltage cable will be connected, and we will be finishing the fire suspension test and system integration. After that, they will be shipped out to the project destination.
Standing inside this facility, I realized this isn't really about batteries. It's about timing, knowing when to capture power, when to hold it, and when to release it back into the world.
Actually, in Kortrong, we control the entire supply chain of the energy storage system. We build our own PCS and build our power equipments.
Wow.
So that's why we control the entire components of the system to make sure it's reliable and stable.
So I think that's what makes it sort of exciting for your company, because you guys can control all aspects, right?
Yes, all assets, and it's all controlled by us. So we have more confidence on investing some projects overseas.
As a musician, this felt deeply familiar. Music is also controlled energy. You don't just make sound, you decide when silence ends. What impressed me most here wasn't speed, it wasn't restraint. Nice to meet you, Richard. Thank you for having us.
Nice to meet you.
You have 26 years of experience in power electronics, have also led the National 863 program. Why did you choose to develop energy storage in 2018? And why did you choose the path of self-production across the entire industry chain? What opportunities did you see?
我们做储能，是因为我们相信能源转型必须依靠储能。储能是新能源发展的稳定器，没有它，风光发电的稳定性、电力供需的实时匹配都很难得到解决。2018年呢，我们看到新能源时代即将到来，因为中国的“十四五”规划有几亿千瓦的新能源装机容量，在当时呢，储能各种技术路线不断的涌现，但是我们最后经过成本、性能和匹配性上，选择了锂电池的电化学储能的技术路线。实践证明，电化学锂电池的这个电化学储能是最具有经济性，也是能最快适应新能源发展的技术路线。至于为什么我们要做全产业链的技术自研，这是我们科创的战略选择。因为储能是一个资本密集、人才密集的一个行业。如果我们不做全产业技术自研，没有把核心技术掌握在我们自己手上，我们很难实现世界级的技术竞争力。在这条路上，我们没有第二选择。
For a company to succeed in energy storage, it needs a forward-looking vision and comprehensive control over green energy system. How does Kortrong embody these 2 points?
这个问题很好。我们2018年呢，大力投资储能，它是一个具有金融属性的综合性产品。我们必须从顶层设计，系统性的解决这个全生命周期的核心的相关问题。为此呢，我们针对储能的特点进行了相应的技术开发。针对它的安全性，我们开发了全静默式的液冷技术，彻底解决了储能安全性的社会难题。作为一个金融产品属性的这么一个储能，我们通过它研究它的市场化交易，以及它的智能化运维，来实现储能作为金融产品它的一个金融的稳定收益和全生命周期的可靠运维。我们呢不仅仅是研究储能的应用，我们通过储能来构建生态，我们通过储能的勾网性技术来构建新型的智能微电网，也就是我说的绿色电力。我们通过我们的这个液冷技术、成熟技术，同样应用在算力系统，让服务器的能耗降30%。通过我们这种模块化的集装箱技术，实现快速的部署。然后呢，我们用稳定的这个微电网，又为我们的绿色交通提供这个稳定的、低成本的、充足的电力，为中控卡的快充系统实现落地提供了可能。所以科创现在不是一个简单的设备供应商，它是一个生态的缔造者。
Well, Richard, it was a pleasure to be here visiting with you today. You know, obviously what you've built here, Kortrong is just, I had the pleasure of seeing everything, and it's just a great contribution to the world. I hope I can visit with you again, you know, and thank you for giving me the time to come here and visit with you today.
It's my pleasure.
Oh,
Thank you, Omar.
thank you, Richard. Thank you very much. Nice to meet you.
通过这次的采访，希望呢你能把我们科创的产品、科创的文化带向世界，也能把中国的文化带向世界，让我们增进了解，增进互信。
In a world where energy increasingly supports cities, data, hospitals, and daily life, trust becomes as important as innovation. Out here, energy doesn't come from a switch. It comes from patience,